So welcome to today's free educational webinar on dispatch and system controls in the HOMER Energy software. I'm Marilyn Walker, Chief Operating Officer here at HOMER Energy, and I'm excited to be here with you today and really appreciate you showing up. Our plan is to make these educational webinars monthly so we keep you up to date on what's happening in the world of HOMER and how to best use the HOMER software in our services. So I have three HOMER experts with me in the room today here. Aarabi Madhavan, an engineer on our product team, Diwakar Rajasekaran on the support and demonstration team, and Steffi Clowett, our product manager. Aarabi is going to demonstrate the products, and then Diwakar will help you with your questions. So just a quick review. HOMER is an acronym for Hybrid Optimization of Multiple Energy Resources. The HOMER approach includes three different processes nested together. At its core, HOMER has a simulation engine that simulates the operation of an electric power system for 1 year, hour by hour, or minute by minute. At each time step, HOMER looks for the most cost-effective way to meet the electric load based on the set of constraints that the user defines. While simulation tells you how one system operates, the optimization step simulates hundreds of different systems to find the least cost system. And then HOMER has an option to do sensitivity analyses, which allows you to look at the impact changes in variables that you don't have control over, such as fuel price or wind speed, could have on your system design and system costs if you got those wrong. So using HOMER to design or optimize your microgrid has three main steps. First, you're going to provide information on the economics, such as interest rate, along with your energy demand profiles, your location, that's going to give you the renewable resources, solar radiation and wind speed, and then the types of equipment you want to consider, shown here as the system components. HOMER then steps through the three nested processes I talked about in the last slide, simulation, optimization, and sensitivity, and then provides detailed results not only on the economics of the system, but also on exactly what's going on literally in every hour. Control algorithms, or what we call dispatch strategies, sometimes in HOMER, is the way in which the microgrid controller makes decisions on which components will serve the load when. So dispatch strategy is one of the choices you make when you set up your HOMER modeling run. HOMER is the only microgrid modeling software tool that offers you 6 different control choices out of the box and also lets you design your own control system. In last month's webinar, we went through the 6 control strategies that are out of the box, and later we can tell you how to reach that video. And then today we're going to have you look at how to create your own strategy and have HOMER use that. So today we're going to be focusing on HOMER Pro, our flagship product, and it's our more versatile product. I also want to mention HOMER Grid, which was explicitly designed for behind-the-meter systems in grid-connected markets, where demand charge reduction, time of use rates, maximizing self-consumption, incentives, resiliency, or some combination of these are what matters the most. These are the strategies, just quickly, that are already in HOMER that you can get straight out of the box, 5 in HOMER Pro and 1 in HOMER Grid. The first 4, cycle charging, load following, combined, and predictive, are all used mainly for purely off-grid systems. Some of them, particularly the predictive one, has only 1 gen set. Then we introduced a generator order dispatch for island utilities or small utilities that have multiple generators. And then, of course, the peak shaving dispatch in HOMER Grid. Okay, so now I'm going to turn it over to Aarabi Madhavan, who's going to demonstrate the MATLAB link and controller API options.
In the previous webinar, we covered the 6 dispatch strategies in HOMER Pro and HOMER Grid. Today, we're going to discuss the 2 ways to add a custom dispatch in HOMER Pro, one using MATLAB link and the other using controller API. So if you're writing a custom dispatch, where does it fit into the HOMER framework? At its core, HOMER is a simulation model. It attempts to simulate a viable system for a particular system configuration. Now, how the system is simulated depends entirely on the controller being used. So when you write the custom dispatch, you're essentially changing how the simulation occurs. Even with your custom dispatch, you can still use HOMER to optimize from thousands of possible system designs and also use HOMER to model sensitivity variables and their impact on your model. Now let's look at the differences between MATLAB Link and controller API. So the main difference is in the programming language you use to write a custom dispatch. If you're using MATLAB Link, then you'll be coding that in MATLAB, and in controller API, you'll be using C++. Now let's say that you would like to share your custom dispatch with a client or a customer. And if you develop the custom dispatch using MATLAB Link, then you'll have to send your 3 MATLAB files to that client. And as you might know, MATLAB files can be opened in any text editor. So there's no privacy for your code. If you're using the controller API, then you're guaranteed more privacy. And this is because the C++ code is bundled and compiled into a DLL file, also called Dynamic Link Library. For those of you who are not familiar with DLL files, it's similar to an exe file. The only difference being that an exe file can run by itself, while a DLL file needs another application to run it. So in this case, the custom dispatch that you write in C++ and later convert into a DLL file will need HOMER Pro to run it. And the final difference is if you would like your controller and custom dispatch to be distributed as part of HOMER Pro software, it's possible only using the controller API. If you have used HOMER Pro before, you know that HOMER Pro offers a wide range of components. But if you're using the external dispatch, either MATLAB Link or the controller API, then the access to these components is limited. You can access these 9 components that you can see on the screen here. So generators, PV, wind turbines, storage, converters, flywheels, custom component, grid. Now let's dive into MATLAB Link. If you decide to build a custom dispatch using MATLAB Link, then you will need to install HOMER Pro. A version greater than 3.7 will work. We're currently on 3.12.3. You also need to purchase MATLAB Link module. And you also need to have MATLAB installed on your system. It's important to note that if you're using 32-bit HOMER Pro, then you need to use 32-bit MATLAB. And if you're using 64-bit HOMER Pro, then you need to have 64-bit MATLAB. When you're writing a custom dispatch, data is passed between HOMER Pro and MATLAB. And it's important to familiarize yourself with the data structures you'll be dealing with. So the first data structure is simulation parameters. This structure is read-only, and it does not vary with every time step. And the information from simulation parameters could be if a generator is present in the model, or if the PV is present on the AC or DC bus. Simulation state, on the other hand, is a data structure that you will need to set in your custom dispatch. And variables in this data structure will vary with every time step. An example would be maximum charge and discharge power of a battery in a particular time step. The third data structure is custom variables. It's optional, but you can choose to create your own variables to use in your dispatch. Now, if you would like to access the variables under each of the 2 data structures, simulation parameters and simulation state, you can do so by going to our online help documentation. We have a section called MATLAB Link under controller. Now let's look at the process of when you're using MATLAB Link controller. So in this diagram from top to bottom is the process from when you hit calculate in HOMER Pro till the point in which the calculate is complete and you're able to view the results. So the first step that happens is HOMER Pro opens an instance of MATLAB and sends simulation parameters to the MATLAB workspace. HOMER Pro then runs the start simulation function, and this is an opportunity where you can evaluate the system being simulated and send any errors back if needed. If HOMER Pro does not detect any error from start simulation, then it proceeds to step 2. Over here, it generates simulation state and sends that to the MATLAB workspace, and then calls the dispatch function. Now, dispatch function is an opportunity for you to control how the components are used to meet your load and operating reserve requirements. Step 2 is repeated until all time steps are simulated. And once all time steps are simulated, then we move on to the third step, in which HOMER Pro calls end simulation. Any errors reported in this stage will be shown in the HOMER user interface. Now let's watch a quick demo of the HOMER Pro MATLAB Link.
In this demo of the HOMER Pro MATLAB Link, let's begin by creating a new HOMER model. I'm using the 64-bit HOMER Pro and adding an electric load. I'm also adding a 20 kilowatt generator and a 30 kilowatt PV panel. If you look at the schematic diagram on the left, you can see that we have an electric load on the AC bus with a 20 kilowatt peak, a 20 kilowatt generator, and a 30 kilowatt PV panel. Now let's move over to the controller menu. When you create a new HOMER file, you will observe that two controllers, HOMER cycle charging and HOMER load following, are added to the model by default. For the purpose of this demo, I will be removing these controllers and adding HOMER Pro MATLAB link from this drop-down. Now if you observe the controller page, you will see that HOMER Pro has automatically detected the MATLAB version on my system. I'm using the 64-bit HOMER Pro, and it's found the MATLAB install directory path for the 64-bit MATLAB. Now if you're using 32-bit HOMER Pro, it's going to search for 32-bit MATLAB. If you find that this path is incorrect, you can choose to manually enter the path by checking this box. The next input is this working directory. This is the directory where you'll be storing the 3 MATLAB files. The next 3 inputs are the name of the 3 M files in that directory. You can see that they're already pre-populated, so you can choose to use the same names for your M files or create new ones if you would like. Now before I create the 3 MATLAB files, let me show you how to access the list of variables you will need to use in your code. We have an online help documentation for HOMER Pro, and there's a section MATLAB link under controllers. And over here you'll find 2 articles that list the variables in simulation parameters and the variables in under simulation state. Now let's go to the MATLAB workspace. I'm going to create 3 M files and name this one MATLAB start simulation. MATLAB dispatch, and the last one MATLAB end simulation. Now let's write MATLAB start simulation. The MATLAB start simulation function checks the problem and returns errors if needed. It's also an opportunity for you to define any custom variables. You can see that MATLAB start simulation has one input, simulation parameters. This data structure contains all information about the current system being simulated. Let's say, for example, you're writing a dispatch algorithm that works only for batteries on the AC bus. But someone else who's using your dispatch incorrectly builds a model with batteries on the DC bus. So this is where you can check their model, use simulation parameters to check if the batteries are on the AC bus, and if they are not, you can then send back an error. And the 2 steps to sending back an error message, one is you need to set an error description describing what error their model has, and the second one is a severity code. The severity code can either be a simulation error or a critical error. If it's a simulation error that you're sending back, it means HOMER Pro will skip the entire simulation. If it's a critical error, HOMER Pro will skip the rest of the calculation. In this example, you can see that we've also created a couple of custom variables. Let me go ahead and save this example and then create MATLAB dispatch. MATLAB dispatch has 3 input variables: simulation parameters, simulation state, and the custom variable we just created in MATLAB start simulation. Now simulation parameters is a data structure that contains variables that define that HOMER problem. They're read-only and they cannot vary with every time step. Simulation state, on the other hand, is a data structure that does vary with every time step. And in this dispatch, you will be setting many of the variables in simulation state. Our model is a very simple model. It has one PV and one generator. So let's go ahead and write our dispatch algorithm. So the first step is to use all the PV to serve the load. My second step is to check for any unmet load. And if there is any unmet load, then I use the generator to meet that. My fourth step is to actually serve the load. My last step is to set excess electricity, unmet load, capacity served, and capacity shortage. Now let's write step 1. It's always good practice to first check if a component exists in a simulation before actually using it. So that's what we're doing over here. We're checking if simulation parameters has PV, and if that's true, then we're setting the power set point of the component. My next step is to set unmet load. I'm calculating unmet load by subtracting the PV production from the load on the AC bus. My next step is to check if this simulation contains generators, and if it does, then I can use it to serve the unmet load. Before we set the power set point of a generator, we need to know the boundaries of the maximum power available from a generator and the minimum load ratio. Keeping those two constraints in mind, we can then set the power set point. Now, if there is no unmet load, then we can go ahead and set the power set point of the generator to be 0. My next step is to actually serve the load. If you observe all the steps until this point, we have only set the power set point of the components. We haven't actually served the load. You can do so by setting the load served variable in AC bus as well as the loads served under primary loads. My last step is to set excess electricity, unmet load, operating capacity requested, and capacity shortage. The operating capacity served is the sum of the total power available from a generator and the total PV production in this time step. Let me go ahead and save this file. The last file we need to create is MATLAB End Simulation. The MATLAB End Simulation function generates errors or warnings and returns them in this myErrors variable. If you set warnings in simulation warnings, they will appear in the HOMER optimization table on the results page with the warning icon next to the simulation. Let me go ahead and save this file. Now that we have the 3 M files ready, we can go back to our HOMER model and hit calculate. At this point, if you have your task manager open, you should be able to see MATLAB.exe in the process list. You will find that using HOMER Pro MATLAB link is a little slower than using the HOMER internal dispatches because there's a lot of information and data going back and forth between HOMER Pro and MATLAB. Alright, so we see that we have found a feasible solution with our dispatch algorithm. For a 30 kilowatt PV and a 20 kilowatt generator, we have found a feasible system with a cost of energy of 51 cents. You can then double-click the simulation to get detailed information. This concludes this quick demo of HOMER Pro MATLAB link. You can find more examples at success.homerenergy.com. Thank you.
Hi, this is Marilyn. So I think Aarabi's going to just start another demo now of the controller API.
So in order to build a custom dispatch using the controller API, you will need HOMER Pro, and you also need to have purchased the controller API package. That package gives you documentation and help on how to develop your code in C++. And you also need to have C++ development environment set up on your machine So something like Visual Studio would work well. It would allow you to write code and compile that into a DLL file. Now, if you want to distribute a custom dispatch as part of HOMER Pro, then you need to send us the DLL file as well as the XML page file for the controller page. ABB's M+ controller is responsible for coordinating the operation of different generation sources and loads. Now, at its core, the Microgrid Plus control system from ABB is designed to coordinate the energy flow within the power network and to ensure that this power flow is always effectively and efficiently managed. This includes ensuring sufficient spinning reserves but without any excess. The other objective of ABB's controller is to maximize the utilization of renewable energy to achieve the best possible return on capital investment. Now, using our controller API, we have developed the ABB M+ dispatch. Because of the controller API, you can now test the performance of your potential microgrid system using ABB's M+ control system. Now, let's watch a quick demo on it.
For this demo of ABB's Microgrid Plus controller, let's begin by going to the controller page. When you create a new HOMER model, you will observe that two controllers, HOMER cycle charging and HOMER load following, are added to the model by default. Each of these controllers have settings that give you some control over the dispatch. For the purpose of this example, let me go ahead and remove these two controllers and then add ABB's Microgrid Plus controller from this drop-down. The M+ controller supports load sharing between generators. You can enter the generator stop hysteresis input to prevent excessive starting and stopping of generators. You can also add multiple rows to define the order of generator dispatch. The M+ controller also allows for solar forecast and advanced energy storage management. Now let's simulate a system using ABB's M+ controller. If you look at the schematic diagram on the left, you can see that we're simulating a large hospital with an existing 1 megawatt generator and a new 650 kilowatt genset. We also have PV and batteries. We can observe that the winning system using the ABB M+ controller has nearly 3000 kilowatts of PV and 300 kilowatt hours of lithium-ion battery along with the two generators. You can double-click the simulation to get more detailed information. The ABB M+ controller was built using the controller API, which means that the dispatch was written in C++ and then bundled into a DLL file you can see here. ABB's Microgrid Plus controller will be available as part of the HOMER Pro software. This will allow HOMER users to test the performance of their microgrid system with an actual controller from ABB.
Oops. Thanks, Aarabi. Great. So we're going to get to your questions. We have a lot of excellent questions. Before we do, I want to just address a few things. One is I'm seeing a lot of questions that are kind of general questions about HOMER capabilities. So this is a fairly advanced topic, writing your own dispatch. And my recommendation, if you don't have that HOMER background, is to talk to our support team about what kind of training materials are available. We have both free trainings and commercial licenses come with a 2-hour online training where you can get all those questions answered. So I'm going to try to really focus on questions today that are about these two API products. Another thing I'm just going to jump ahead here, which is because I'm seeing questions on it, which is how do you get these things? So as Aarabi mentioned, MATLAB link down here, that is that is part of Homer Pro. It is an add-on. It's available with the Expert package, or you can add it on to any other package. And the controller API is a product, a separate product that you purchase. And it's an investment. And you can get more information on it here at our website under Controller API. That'll open up this page that will give you some more general information. And then my recommendation is that you reach out to our sales team about what you're trying to do. So most people are going to want to be using the MATLAB API to start. We introduced ABB's M+ controller. I also want to say that's not available quite yet. We are still working with them on getting it right. Okay, so let me hop back and go to your questions. So can you actually, there is a question on here, can you get a test license? So you can't get, so controller API, you should really be working through MATLAB first. So MATLAB link is included with our trial. Our trial package of Homer Pro includes all the modules. And so if you already have a license and you need a specific test license for MATLAB API, you could speak to your sales representative about that. Okay, so we've got DeWalker on board, DeWalker and Aarabi and maybe Steffi. So DeWalker, I'm going to let you unmute yourself and start answering questions. So can I develop a custom controller using Python or R?
So currently we do not have a custom controller using Python or R, but it's definitely possible. Depending upon the number of customer requests we get for introducing that feature, we can definitely develop that and put it in our product pipeline.
Thanks, Aarabi. Sorry, I got it wrong. Who was going to answer that question? When will M+ be available? I can take that one. When it's ready, a couple of weeks. Where can I get more information on that? That is ABB, actually. It's their product. One of the advantages of the controller API is that you can actually put your technology into Homer without us here at Homer Energy knowing exactly what it does. So I am working with ABB on doing another webinar where they will introduce you to that. So I'll tell them that there was interest. Okay, here's a good question. Is there a list of supported controllers? Can we work with Schneider Electric or only ABB? They want to know if there's a list of supported controllers. Like, why do we only have ABB in there? Do we have Schneider Electric?
Sure. So right now there's ABB will be the first one, but of course we're interested in bridging the gap between Homer Pro as a pre-feasibility solution to the next step. So we're very interested in engaging with other controller companies. ABB happens to be the first one which we've been able to engage with on their controller algorithm. So we're very open to doing more of these projects in the future.
Okay, I'm going to go to a technical question. We've had lots of good business questions. If I have a model that contains a battery and I want to control when it charges and discharges, it mentions that I should set it as a positive value to charge into a negative value to discharge. Can you explain that a little more, please?
Yeah, so the battery structure has a number of variables that you can access, and one of the variable is input set point. And over here, if you're charging the battery, you'll put in a positive number, and if you're discharging, it's a negative number.
Thanks. How about where to find more MATLAB link examples?
So we definitely have more examples with a lot more components than what we showed in today's demo. You can access them at success.homeenergy.com.
Is there a custom component available for hydrokinetic that you could use within the APIs?
No, hydrokinetic is not available using our external dispatches, but we do have a custom component that you can set up as a either power purchase agreement or a renewable resource.
Okay, here's a good one. How do you handle battery dispatch scenarios, for example, charging and discharging with time of use?
So our external dispatch definitely gives you access to the grid component. And in the grid component, you can put in either time of use prices that your electricity tariff has, and you can access that grid component to then decide your battery charge and discharge with time of use.
Okay, can we set in the MATLAB custom dispatch excess electricity to 0, i.e. renewable plus generator supply is exactly equal to the load?
Yes, so if you have not generated any excess and whatever your generator and PV is producing is just enough to meet the load, then you can definitely, and you should be setting the excess to be 0.
Can you install my company's controller into HOMER? Yes, we can. Please contact our sales department. Andy Cruz will get back to you on how to do that. All right, let's see. Okay, this is rather long, but I'll go ahead and read it out. I believe the renewable energy project should also consider the elimination of CO2 and other greenhouse gases. Yes, we agree. Is it possible to simulate and output the value in terms of monetary terms of eliminated gases? I can tell you that, yes, it is possible within HOMER Pro, and I'm going to let Aarabi discuss it relative to MATLAB. If it is not possible, if we code these simulations in C++ or MATLAB, can we integrate to HOMER Pro? Well, like I said, that definitely is in the main product, and I'm going to let Aarabi just weigh in on what you can do.
Yeah, so in our MATLAB dispatch, you have simulation parameters that give you access to the emissions of the generator and the grid component. So you can definitely use that to be able to control how many emissions you're having in each time step.
How do we get a tutorial on how to design a standalone system using HOMER Pro? On our website. Yep, that's all over our website. You'll get a series of videos if you get a trial license that are always up there and available. So go ahead and reach out to our support team if you need to, support.homerenergy.com. Okay, I'm going to go back and let Aarabi answer this one. Does MATLAB dispatch need to change? You know, if I have a MATLAB dispatch I've created and I get a new version of HOMER Pro, what happens?
So the data structures that we'll be using will not change between versions of HOMER Pro. So if you've created a custom dispatch in, let's say, HOMER 3.12, and we have then released 3.13, then you should be able to use the same dispatch in the newer version of HOMER Pro.
Okay, you did not show anything of how to feed the controller API. Is there a technical specification? So the way we always want you to start is with MATLAB. So MATLAB is just a way of using a scripting language to work with your own custom components or your own custom controllers. And then if you're interested in working with us on a controller API project, which is a larger investment, we can get you all that. But my understanding is that they're pretty similar. They're just really, as Aarabi showed earlier, they're really just different ways of accomplishing the same thing, one that runs in a slow scripting language and one that can be distributed. Okay, yeah, that's a great question. Can you explain the API in more detail? What interfaces are used? I know you covered some of that, but it goes by fast. What interfaces are used and what documentation is available for MATLAB?
Oh, so the HOMER Pro interfaces with the MATLAB.exe. So when you're using HOMER Pro MATLAB link, HOMER Pro calls MATLAB.exe and then passes the data to that workspace and then calls the 3 M files that you have created in your custom dispatch. You will, as much as I know, you will not be requiring special libraries in MATLAB to create this dispatch. You can just, as you saw in the demo, you can just straight away just use the data structures available from Homer and create your custom algorithm.
Will it become possible to use MATLAB Link and Homer Grid? And I can go ahead and take that one. We don't have any plans to do that. And the reason is that the Homer Grid product is really all about the proprietary dispatch that we wrote to let Homer deal with peak shaving, which was really fundamentally different from how Homer Pro kind of sees the energy world. So no, you could certainly play. So you should, I'm going to put this over to one of our engineers, but I would think that Homer Pro would be the right, it's the Swiss Army knife, but I'm going to let Aarabi weigh in.
Right. So the architecture for Homer Grid is not set up to allow for external dispatches. So if you want to create external dispatches, we suggest using Homer Pro. And obviously, there's a lot of flexibility with writing your own dispatch. So if you would like, then you can create your own custom algorithm for peak shaving using the MATLAB dispatch.
Okay. Yep. Just a couple more. Again, there's another question about help information on MATLAB Link. Is there a technical specification for C++ examples? So again, it's really the same thing. You could work on MATLAB, and but if you have specific questions about our controller API, do you want to take that, Aarabi? Okay, I'm gonna.
Yeah. So we do not release any help documentation for our controller API. It's a different process to get you started in creating custom dispatch using that API. It's a lot more protected because that custom dispatch can then be part of the Homer Pro software. So ideally, you should be contacting someone in our sales team to get more information on that API.
So how does the Homer engine determine how much time is required to charge the batteries to a certain state before it's ready for another dispatch?
So I'm not clear on the question. Is it, we don't switch between dispatches. For every simulation, we just pick one dispatch and then we use that dispatch for the 8760 timestamps.
Right, so it wasn't my question. I actually think the answer to that question is, you set that time step when you set up your model. So you can set the time step to be minute by minute or hour by hour, and or anything in between. So each one of those is considered sort of a dispatch event. And Homer's always going to look at the state of your components and what it thinks is the best choice for that next period of time. Is there any way one can export a Homer file to simulate in MATLAB?
So you can use Homer, you can build your model in Homer Pro and then interface with the MATLAB dispatch to connect the dispatch and Homer Pro. I'm not sure about what you mean by exporting that model, but ideally Homer Pro and MATLAB will work together to give you results for your system.
Thank you, and thank you to all of you for your great questions and your presence here today. We really appreciate it. Just to kind of end, our goal for today was just to provide an overview of how to use these things and to experiment with your own control algorithms. If you do have a commercial product, and this is really for a commercial product, we would ask you to consider using the controller API to be able to release your strategy in Homer. We just wanted to sort of show you today how that's possible. I want to make sure that everyone knows we can assist you with any aspect of Homer. So you really don't have to sort this all out on your own. We can do your Homer modeling for you. We can help you learn Homer. We can help you learn these things. So we have many support and training packages available on our website, and so I encourage you to take advantage of those. So next month's webinar, which will release the we're going to release the sign up for that with the recording for this one. We'll be talking about how Homer models storage. and why our advanced storage handling is really critical to accurately understanding your project costs. So we're going to compare the HOMER basic storage model, which is similar to some of the other things out there in the market. And then we're going to talk about, with Jonathan Auerbach, who really wrote the advanced storage model, why this really matters. So I think that'll be a really good one. I already talked about how to get the MATLAB link. And if you market a controller, how do you get someone to talk with you about that? And again, if you didn't get your question answered, send it in through your sales rep or our support desk. And we hope to see you next month to learn about advanced storage options. Thank you.